we just saw that we can get r in terms of some constants times n squared. And so we can see then that the radial distance, if we think about these as fixed circular orbits, depending on what the value of n is, then that next level, so if you go from, say, n is equal to 1, then you go to n is equal to 2, you have 2 squared, and you have 4 times a larger radius. And then if n is equal to 3, n squared is 9. And this is shown on the bottom right diagram, showing how these radius between these different n levels increases as n squared. All right, we said at the beginning of this slide that we were looking at this total energy, and we had these two variables, v and r, and we now can substitute in, at least for v, which we already had v squared. So going back to this here, we have E is equal to 1/2 m, and now we'd substitute in that v squared, k E squared over mr, and then that is minus this potential energy. And luckily, this is pretty easy because the m's cancel, and we can bring out this constant term of this k E squared divided, well, r is not constant, but we have k E squared and then divided by r, and then we just see that that is 1/2 minus 1 multiplied by that. So that gives you a minus 1/2 of this term. So k E squared divided by 2r. So that's our total energy. And now we can substitute in that r value that we had above. So if we do that, we'll call this En, and what this is saying is that this r value is in terms of n, the quantum number that we've introduced. And so if we do that, we get a minus k E squared divided by 2, and the inverse of r is then m k E times E squared over n squared h bar squared. And that is, we can simplify that slightly, but we'll see that that's all a constant times 1 over n squared. And so what we'll then say is if you gather together those constants, you'll get a energy, which is a minus 13.6 eV multiplied by 1 over n squared. Okay, now the negative might seem a little bit strange, and I should explain that. We're looking at a bound system, which means that the electron is, we assume, always going to be orbiting at this radius. And the energy that you would need to unbind the electron, and if we remove an electron from an atom, that's called ionization, we'll see that if you choose the value of n is equal to 1, then you would need an energy of 13.6 eV inserted into the system, either through a collision or some other way of providing energy, such as a photon. And that, if it's more than that energy, you could bump out the electron. So this is what we've got for our energy at a fixed value of n. And what we're going to do then is look at these